All right, today we're going to get our hands dirty. We are going to build a basic computer network right from scratch. And you know what the best part is? You can do this completely for free using a super powerful simulation tool that pros use to practice. So, let's just dive right in.
You know, this quote right here, it absolutely nails what we're about today. Networking isn't just some theory you can cram from a book. It's a real practical skill. To truly get how devices talk to each other, you've got to be the one to connect them, configure them, and actually see it happen.
So, how do we start pedaling? Well, for that, we're going to use this amazing tool called Cisco Packet Tracer. It's basically a network simulator. Think of it like a safe, virtual sandbox where we can build networks, break them, and fix them, all without needing a single piece of real hardware. This is our digital bicycle.
Okay, so here's the game plan. We'll start at our virtual construction site, then we'll see how it stacks up to the real world. After that, we'll give our devices unique addresses so they can actually find each other, test if they can talk, and finally, celebrate building our very first working network.
All right, first things first. We need to lay out our components. You know, just like an architect draws up a blueprint before the first brick is laid, we're going to create the map of our network right inside Packet Tracer.
And it's really simple. Just 3 steps. First, we'll drop in a switch. That's going to be the central meeting point for our network. Then we add 2 laptops. And finally, we'll connect each laptop to the switch with a virtual Ethernet cable. And just like that, our basic layout is done.
Okay, so here's what's so cool about this whole setup. What we're doing in this simulation is an almost perfect mirror of how it works with actual physical hardware. Let's take a look at how our virtual parts compare to their real-world twins.
So inside our simulator, we've got this switch. Think of it as the traffic cop for our tiny network. It's the central hub that lets our 2 laptops connect and hopefully start sharing information.
And here's the real deal, a physical Cisco switch. The key takeaway here is that every single click we make in the software directly mimics what a network engineer would do with this actual hunk of metal. The principles, they're exactly the same. So back in the software, it's super simple. We just click and drag a virtual cable from the laptop's network port over to one of the switch's ports. You'll see names like Fast Ethernet or Gigabit Ethernet. That's just talking about speed. It's a simple drag and drop and the link is made.
And if you were doing this in the real world, this is what it would look like. Now, I know what you're thinking. Most new laptops don't have that chunky Ethernet port anymore. But hey, that's what these little USB adapters are for. So the skill is totally transferable.
Okay, so we've built the physical structure, right? The cables are plugged in, but right now these devices are basically strangers to each other. They're in the same room, but they don't know each other's names. Just like a house needs a mailing address, our laptops need network addresses to talk.
The first and probably most famous type of address is the IP address. This is a logical address that we actually get to set up ourselves. It tells the network exactly where to send data, just like the Postal Service needs your street address to deliver a package.
Then you've got the MAC address. This is totally different. It's the device's permanent physical ID burned right into the hardware from the factory. So if the IP address is where you live, which can change, the MAC address is who you are. It's a permanent serial number.
So how do we get these IP addresses? Well, there are 2 main ways. You might be thinking, I've never done this for my home Wi-Fi. And you're right. That's because most home networks use DHCP, where the router just hands out addresses automatically. But for us, we want to learn how it works under the hood. So we're going to do it manually. It's called static configuration, and it gives us total control.
All right, time to give these laptops their addresses. We'll make laptop 1 192.168.1.1, and laptop 2 will be 192.168.1.2. And that subnet mask, don't let the numbers scare you. Just think of it like a zip code. Having the same one tells both laptops, hey, we're in the same neighborhood. We can talk to each other directly.
So, once we've punched in those numbers, how do we know what actually worked? Easy. We use a super important command you'll use all the time, ipconfig. We just type that into the command prompt on our virtual laptops, and it'll spit back the configuration we just set up. It's our proof.
Okay, this is it. The moment of truth. We've laid the physical foundation, we've given our devices their digital identities. Now we find out if all our work paid off. It's time to see if they can actually talk.
So on paper, everything looks perfect. The lights are blinking, the addresses are set, but in networking, you always have to test. You never just assume it works. The big question is, can laptop 1 actually send a message to laptop 2 and get a reply?
The tool for this job is called ping.
It's one of the simplest but most powerful tools there is. It's basically the network version of shouting, "Hey, are you there?" and waiting for a "Yeah, I'm here" in response. It sends a tiny packet of data and just waits for an echo. And boom, there it is. From laptop 1, we type ping 192.168.1.2. And a second later, we get that beautiful line, reply from 192.168.1.2. That little message, that's everything. It means our signal went from laptop 1 through the switch to laptop 2, and the reply made the entire round trip successfully. We have communication.
So let's just pause for a second and really appreciate what we just did. This wasn't just about clicking a few buttons or typing a command. You just successfully designed, built, and tested a working computer network completely from scratch.
I mean, think about what you just did. You laid out a network topology. You cabled the devices, you configured IP addresses by hand, and you tested it all with a professional command line tool. These skills, these are the absolute rock-solid fundamentals of all networking.
So remember that bicycle analogy from the beginning? You just did it. You stopped just watching videos about how to ride. You actually got on that virtual bicycle. You pushed the pedals when you configured those IP addresses, and you rode it down the street when you sent that successful ping.
You have literally just made two computers talk to each other from nothing. This simple two-laptop, one-switch setup, it's the building block for everything from your home Wi-Fi all the way up to the entire global internet. You've laid the first brick. The real question is, what are you going to build on top of it?